Types of disk scheduling algorithms. First come first serve, FCFS. FCFS is the simplest of all the disk scheduling algorithms. In FCFS, the requests are addressed in the order they arrive in the disk queue. Advantages: every request gets a fair chance. No indefinite postponement. Disadvantages: does not try to optimize seek time. May not provide the best possible service. Example: given the following queue, 95, 180, 34, 119, 11, 123, 62, 64 with the read-write head initially at the track 50 and the tail track being at 199. Let us now discuss the different algorithms. All incoming requests are placed at the end of the queue. Whatever number that is next in the queue will be the next number served. Using this algorithm doesn't provide the best results. To determine the number of head movements, you would simply find the number of tracks it took to move from one request to the next. For this case, it went from 50 to 95 to 180 and so on. From 50 to 95 it moved 45 tracks. If you tally up the total number of tracks, you will find how many tracks it had to go through before finishing the entire request. In this example, it had a total head movement of 640 tracks. The disadvantage of this algorithm is noted by the oscillation from track 50 to track 180, and then back to track 11 to 123, then to 64. As you will soon see, this is the worst algorithm that one can use. Shortest seek time first, SSTF. In SSTF, shortest seek time first, requests having shortest seek time are executed first. So, the seek time of every request is calculated in advance in queue, and then they are scheduled according to their calculated seek time. As a result, the request near the disk arm will get executed first. SSTF is certainly an improvement over FCFS as it decreases the average response time and increases the throughput of system. Advantages: average response time decreases. Throughput increases. Disadvantages: overhead to calculate seek time in advance can cause starvation for a request if it has higher seek time as compared to incoming requests. High variance of response time as SSTF favors only some requests. Example: given the following queue, 95, 180, 34, 119, 11, 123, 62, 64 with the read-write head initially at the track 50 and the tail track being at 199. Let us now discuss the different algorithms. In this case, request is serviced according to next shortest distance. Starting at 50, the next shortest distance would be 62 instead of 34 since it is only 12 tracks away from 62 and 16 tracks away from 34. The process would continue until all the process are taken care of. For example, the next case would be to move from 62 to 64 instead of 34 since there are only 2 tracks between them, and not 18 if it were to go the other way. Although this seems to be a better service being that it moved a total of 236 tracks, this is not an optimal one. There is a great chance that starvation would take place. The reason for this is if there were a lot of requests close to each other, the other requests will never be handled since the distance will always be greater. Scan algorithm. In scan algorithm, the disk arm moves into a particular direction and services the requests coming in its path, and after reaching the end of disk, it reverses its direction and again services the request arriving in its path. So, this algorithm works like an elevator, and hence also known as elevator algorithm. As a result, the requests at the mid-range are serviced more and those arriving behind the disk arm will have to wait.
Created using Powtoon.